So yesterday you guys got to go around and you did a little activity where you were doing some surface areas of different shapes. So adding them together, subtracting them together. Today we're actually going to look at the review piece of that. Okay, so yesterday was just a fun bit to see what you remembered. Today will be okay, what are these formulas again and how do we use them? And a lot of you did really, really well with that. So you're remembering how to do that, which is good because that'll only make this unit a lot easier when we start getting into the 3D portions on Monday. So we're going to be pretty just easy peasy today and do some of the same kind of formulas that we did yesterday. And we're going to be working with the areas of two-dimensional figures. And then next week we'll be looking at prisms and pyramids and those spheres. The sphere and the cylinder are the main two that we use a lot in this one. Um, and we're also going to have to figure out sometimes if we don't really have the slant height of a pyramid, or if we have the apex height of a pyramid, we actually need the slant height. So we're going to be doing a review of Pythagoras during this unit as well. Okay, so the ones that we're going to look at are squares, rectangles, parallelograms, triangles, and circles, because most 3D shapes are made up of a variety of those. Now, surface area is the stinky one where if the surfaces are touching, we have to take them out, and that's why it becomes a little bit confusing. So just a quick review. We've got our rectangle, length times width, right? Everybody remembered that one almost right off yesterday. The next one, square, we can use either s squared or we can continue with just length times width. The only thing with a square is that the length and the width are equal, so we just call it a side and square it. So if you just want to use one formula for both the square and the rectangle, that's the one to use. It's not going to matter. Parallelogram. Now we're still using kind of a length and width, but because it's pushed off to the side, the width is now called our height. Right, so that would be comparable to that. And then we've got our base, which is the same as our length. Right, Alejandro? I see you looking down at your phone there, so intent again. So if we go back to our rectangle, the length we can also say is a base. And our width we can also say is a height. Now the reason I'm comparing those is because when we get into more complex 3D objects, we're not going to see a lot of length and width. We'll see more base and height. Because when we have 3D, we'll have base, height, and then we'll have like one or two other dimensions in there. And then our triangle, 1/2 base times the height, also known as base times height divided by 2, or area equals base times height divided by 2. So using any one of those three formulas, right? It's fine. You can take 1 divided by 2 and multiply by the base, multiply by the height, or you can multiply the base and height first and divide it all by 2, or you can even just write it not in that fraction form because sometimes that little line scares people. Our circle, pi r squared. R is the radius, the distance from the middle to the outside. So if they give us the diameter, right? So this is the important piece here, is remembering that the distance across the whole circle is actually called the diameter. And we never use the diameter. Okay, we don't want the diameter in any of our formulas except for maybe the circumference one. We can use diameter or radius, but then they're two different things, right? So from now on, anytime they give you the distance across a circle, you always want to diameter divided by 2 to give you the radius. We're always going to use radius when we're talking about volume and surface area, which is what we're going into, right? So that's just one of those key things to keep off to the side. Well, they gave me the diameter. I better split it in 2 before I use it. Okay. And then our lovely trapezoid, which we looked at yesterday at one of the stations in the back. And we can also just rewrite this to be the area is equal to the top side plus the bottom side, making sure that's in brackets, multiplying it by the height, and either over 2, or again, if you don't like those fractions, your two top and bottom sides times the height divided by 2. Okay, so whichever one of those works for you. Each of you are going to have a little bit of a different preference. Okay, so those are the ones that we're going to deal with, those kind of 6 basic shapes. And most of our compound shapes and most of our 3D shapes are made out of a variation of these guys put together. Okay, so if all else fails and I can't remember the formula, or I don't have the formula for a pyramid, for example, like a pyramid looks like this, right? When I talk about pyramids and prisms, I'm talking about a pyramid has a point on the top, the apex where they meet. The prism would be this, right? A box. Yes, sir. Yeah. Okay, so if I had a square or a triangular based pyramid, there's my triangle base, it would meet up at a point, right? Just like the Egyptians have there. And a triangular based prism, right, would be very different. So we could always, if we don't have formulas for something, break them apart into what we call their nets. You guys remember that net thing from last year? We had to try and draw this thing, and there was the flower one at the back there, station 4 yesterday. So we'd have to actually cut along the seams and draw that. So example, I actually with my grade 10s was doing that this morning. This would be the example of a net, right? It's a cylinder when it's built, but the net itself is a rectangle and 2 circles. So this would be a square and 1, 2, 3, 4 triangles. So that's where our formulas come from. We just combine them together to make them a little bit more efficient, because math is efficient. So if all else fails, we can definitely just break apart the parts. So next page on here, we want to actually calculate the area of each figure. So let's start with this guy. The first thing is, well, what is our shape? What's our shape here? A rectangle. I know sometimes we get in the habit of calling it a square. It's not a square unless all the sides are the same. Does 6.5 equal 6, or 4.5 equal 6.8? No, so this is a rectangle. So from the page before, what was our surface area of a rectangle formula? Length times width. Okay. Now, if you're not really great at these, then you might want to follow the 5 kind of steps really like on paper and write them down. But once you start getting used to them, then you can, skip a couple and not really write them so formally down. So my first step, I always want your formula. Okay, this is a non-negotiable. You need to write your formula down for a full mark. Your second step is tell me what your variables are equal to. Variables meaning the letters you have in your equation. So I've got A, I've got L, I've got W. I need to identify what information I have and what I need to replace. So area is what I'm looking for, so it's just going to stay. What is my length? 6.8 centimeters. And my width? 4.5 centimeters. Now, you don't have to do this. I suggest highly that for the first little bit you're doing it, but once you have, you can visualize and say, okay, I know what my replacements are, you might even just want to go, okay, this is my width, this is my length. Just label them to keep them straight. Now, your third step is to actually go ahead and replace those into the equation. So length is going to be replaced with 6.8, and width is going to be replaced with 4.5. Now remember, if they're brackets back to back, that means times. Okay, that's another non-negotiable. I need the formula, I need the equation, with the numbers. So maybe at this point you looked at it and you said, okay, well, I know it's a rectangle, it's length times width, but I don't know how to do it, so I'm not going to write anything down. Well, you would have gotten a mark if you at least wrote area equals length times width. Okay, so your third step is to actually calculate. So what's 6.8 times 4.5? 30.6? 30.6. And kind of the fifth step to this is just double checking. So when I'm looking for your answer, I want you to make sure that you've got your answer rounded to the correct units and that you've got your units on there. So this one, it doesn't say round to the nearest tenth or anything like that, but if it did, then my fifth check before I write that final answer down would be, okay, 30 point, and then I would round 30.6. Then I would go and say, okay, well, I've got centimeters times centimeters, so centimeters squared. Okay, so these are the three non-negotiables. 1, I need your formula. 2, I need your formula with the numbers replaced. And then I need your answer with both rounding correct and your units. If you don't have your units on it, don't get a mark for it. How do I know if they're apples, oranges, snowflakes? If we're talking area, linear. Okay, that is a very important part of it. So that would be like 3 marks on a long answer question, for example. Okay, if you had 2 equations and had to add them together, that would be maybe 3 and 3, 1 for each of the areas. Adding them together or finding the total area at the end would be a 5th or a 6th mark, 7th mark, 3, 6, 7. Right? Like some of these can be quite a bit, but it's also because I know I want to see certain things so that you're getting used to it and you're getting them right. So I will maybe assign a couple extra marks to them to make sure that you put them all down. All right. Let's go a little quicker with this one. Triangle. What is our triangle formula? Base times height. Yeah, 1/2 base times height. So base times height divided by 2. So my base is 12.8. What's my height? 7.8. So my area is equal to my 12.8 times my 7.8. And making sure I don't forget any parts of my formula, divided by 2. So my area is equal to what? What's my area equal to there? 99.84. Do we all agree with that? Do we have a double check on the number? Ah, much better. Much, much better. And if you need to, write down as many steps as you want, right? Write your 99 point whatever divided by 2 and then your final answer after that. Yes, I've got 49.92. They're not asking me to round it anywhere. We just go to 2 decimal places nice and neatly on our calculator anyway, so leave it. And make sure, oh, I've got centimeters, so this would be centimeters squared. Parallelogram. What was our formula? Base times height. Absolutely. All it is a rectangle that's kind of been bent over, right? If we were to actually cut this little piece off here and stick it back here, then it would be a rectangle, wouldn't it? So base times height. What's my base? 3.1 meters. What's my height? 2.1 meters. What is 3.1 times 2.1? What are my units? Ha ha ha, meters squared. All right. How about for a Friday? We do a little bit of that. We got questions 1 and 2. Okay. So get used to using those, and then we can even look at example 2 today in about 20 minutes. Sound fair? Okay. So get used to using some of those formulas again on question 1 and 2. There's, I think 10 and, no, there's 4 and 5, 9. No, there are 10 questions in total there, right? But they should be pretty quick. We'll look at about 15, 20 minutes to get those done for some practice. And then we're going to move on to question or example number 2 after we've had a look at those. Okay? So about 15, 20 minutes of your time right now working with a partner if you want, figuring those out. Just a little bit of practice, get the brain juices flowing. Okay, but let's at least go over a couple of these, get our formulas down, making sure that we know what's going on. Okay? Now, what shape is this? It's a circle. And I know you're like, well, duh. But it says for each picture, name the shape. How many of you guys actually did that? Good, because some of you didn't read, and I didn't see that written down on a lot of places. As he's writing right now. Oh, don't. Okay, so this circle. And then we have to calculate the area. So area of a circle formula is what? Pi r squared. Thank you. Do we have radius? Yes, radius is equal to 44 millimeters. Okay, I don't have the diameter, so I don't got to worry about dividing anything. So area equals pi times 44 squared. Okay, nothing in your formula changes except that you are replacing the variables with the numbers that belong there. Okay, variables are there to give you a general formula. Every time you find the area of a circle, this will work. But then for each specific circle, you want to put the numbers in place of your, for example, radius in this case. Okay, do not forget that if you've got a square, oops, I didn't want that. If you've got a squared here, you need to still have a squared here, right? You don't move it to the pi. You don't drop it or forget about it. You need to still have that there. Because what that really means is area times pi times 44 times 44. So in your calculators, you'd find your pi button, you'd find your 44, and then you'd find your x squared button. So what is our answer for this one? Yeah, I saw a lot of you guys had it right. Somebody can yell it at me. Yes, 6,082. Now, this goes to the nearest whole number, so we can round this to the nearest whole number. Right? If it does not give us any guidance as to where they want it rounded to, take your guidance from the question. Nearest whole number, we'll round to the nearest whole number. Don't forget your units. This was millimeters. Now they're squared because it's areaed. Now your triangle. This messed with you, some of you. So the name is a triangle. What is your formula for a triangle? Divided by 2. Don't forget to divide that by 2. If you just do your base times height, then you've got the area of an entire square parallelogram rectangle. So out of these three numbers, which is your base? Pardon? 9.3 is your base. Which is your height? Right. Remember when we're looking for the or for the height of a triangle, we are going from that top part to the bottom at a right angle. Okay? They gave us what we call extraneous or extra information with that 6.2. We don't need it. Absolutely, it's there. That other length here that they didn't give us right here, that also has a length associated with it. We don't need that, so we're not going to bother with it. So then I go to my triangle formula, making sure that I have the correct number for my basin, which is 9.3 meters, and the correct number for my height, which is 5.7 meters. And then I saw people just multiply those together and forget about the divide by 2. If you got a divide by 2 in there, it's still a divide by 2 in the next step. So what is 9.3 times 5.7 divided by 2? 26.51. Now again, they didn't tell me where to round it to, but my question goes to 1 decimal place, 1 decimal place. I'm going to round to 1 decimal place. So my answer will be 26.5, making sure I've got my units meters squared. Okay? Now let's see. Do we want to do one of these? Nope, they're all just a little bit of practice with that. Okay, so some of you got those done, some of you did not. If you did not, then please go back, making sure that you've gotten all of those done as a little bit of practice. For those of you ready to move on, I'm just going to go over this really quick. Okay? And I'm going to give it to you as an option. We don't really have time to go through it in detail in 20 minutes and get a lot of work done with it. But if you're sitting there and you're thinking, no, you know what, I'm ready for this, let's just have a look. Now, we do not have a formula for this guy, do we? No. It's an irregular shape. It is not something that we can say, oh, look, that's a poly it's a polygonal, hexagonal, whatever. We don't have a name for the shape because it's not a regular shape. It's an irregular shape. But what we can do is we can divide it into parts that allow us to find different shapes within it. So looking at this, what are the shapes that you can kind of see already? A triangle. So if we were to draw like a line right here, we would have a triangle, would we not? Yeah? We could find that area for sure. We could also, yeah, if we, this one, we can either divide here, so we've got those two rectangles, right? We want as few pieces as possible. But we could also take that and divide, or take it and put it there, so we have those three. So either way, like this is going to be, oh, guess what? I get to write my own story with these shapes. You got a triangle, and you've got two rectangles, whether they be this way or this way. I'm going to draw it this way. And we know that the total surface area is going to be a addition of all of them, right? So we've got area 1 plus area 2 plus area 3 is going to give us the total surface area for that. So area 1, do I have all my information that I need for that? What's my formula? What will my formula be for that? Base times height. Sure, we can go with that, or length times width. Actually, because your formula sheet says length times width, I'm going to go with length times width on that. Okay, do I have a length? What is my length? Is it? Are you sure? Ah, you think it's the 13.4 minus 6.2, and you are absolutely correct with that. So with some of these guys, we got to do a little math first. So this length is going to be the total length here minus this length here, right? So you got to figure a little bit sometimes. So that's going to be 13.4 minus 6.2, and what is that? What is 13.4 minus 6.2? 7.2. So that's our length. So our length is 7.2. And what is our width? 6.8. Now, some of you just assume that, oh, well, it looks like a square, so I'm going to make it a square. But it's not, is it? Because 7.2 and 6.8 are not equal. So what is our surface area for that one piece? What is our surface area for this one piece? It's 48.96, which would round to 49.0. I'm going to leave it, though, at 48.96 because I want to round to the nearest tenth at the end. So if you are doing it in parts, always make sure that throughout you at least leave 2 decimal places if you want to round it to 1, so that your final answer is going to be more exact. So how about our surface area here? Surface area 2 is going to be your length times width again, right? So what is our length here? 6.8. Oh, you're going width. Let's keep, if we kept this as length, we're going to keep this as length as well. So yeah, our length here is 6.2. What is our width? And to get that 9.9, you did the 6.8 here plus 3.1 here, right? So length is equal to the 6.8 plus 3.1, which gave us 9.9. So 6.2 times 9.9 will give us what? 61.38. Area 3. What is our formula? Ah, there we go. Divided by 2. So what's our base length? Right, in case you're wondering where 9.9 came from, this would be my base. And that is parallel to this, which is 9.9. What is my height? Yes, my height is 12.6. And then, Dennis, what do I want to do with that? Divide by 2, multiply and then divide by 2. So 9.9 times the 12.6 divided by 2 will give us 62.37. So our final answer for that, because they're asking us to find the area of the total figure, would be that the total area is area 1 plus area 2 plus area 3, which would give us the 48.96 plus 61.38 plus 62.37. So our total area would be 172.71. Now, if you guys left it at that, I wouldn't give you a wrong answer for not rounding correctly because it's a nice, neat number in your calculator and it's more exact, right? But because our answer, because our question only uses one decimal place, 172.7 would be 100% acceptable, making sure that you've got centimeters squared because it's area. Okay, so there's 15 minutes left. In that 15 minutes, you're either finishing off the 1 and 2, or you're going to try um, question 3. I'm not going to assign question 4. Question 4 is out. So questions 1, 2, and 3. Okay. 1, 2, and 3. And then on Monday, we'll start looking at 3D shapes. Fun time.